In this video, we shall next consider line graphs. Line graphs are very, very useful, and we see them almost everywhere on the news in different places in order to show how a particular quantity or quantitative variable varies over some ordered sequence of time. So in this case, for instance, we are looking at people in a store, the count of people in a store, which is of course a numerical variable, and we're looking at the trend, how it varies over time in a day. So typically on the horizontal axis, you have the time variable there, and then you have the count of the quantity being observed over time. Line graphs are very, very useful in illustrating what time series graphs what they do over time or how they trend over time. So here is an example that we would like to build from scratch. In a survey, several people were asked how many years it has been since they last purchased a mattress. The results are shown in this table below. And of course, since it has to do with what years and frequency, it would be nice to have the time variable here, since they last purchased it, and then how frequent does each value of years occur. To do this, we can do this in StatCrunch. So let's head over to StatCrunch. I have the data already computed here. I'm going to go over to Graph, and I'm going to say I want a scatter plot. I know it doesn't sound like line plot, but that is where it is here. So let's go to scatter plot, and I'm going to drag this to the side. On the x-axis, I would like years there. So I'm going to choose years. And on the y-axis, I would like frequency. So I'm going to choose frequency. And I'm also going to indicate that I want a line graph. So for the display, I want a line graph. And for the point type, it's up to you. But I like a field circle. And for the point size and the line size, I want 2 since I'm drawing a line graph. This won't have much of an effect since I'm dealing with what, a line graph. And with that, I am going to drag this up and click on compute. And I can see the line graph, which shows me that that majority of the people we interviewed have bought a mattress have not bought a mattress in the last, 3 years. So that is crucial. And that draws the line graph, which is a very good graphical display for um, data that is based on time and that can be ordered. Here's another example of showing that line graphs, namely time series graphs, can be very, very useful in showing or illustrating trends in time series data. Here's an example where we talk about federal flood insurance underwritten by the federal government and initiated in 1968. And the federal flood insurance coverage has, according to USA Today, more than tripled between 1990 and 2004. That was the report. To check if that report is true, we have a file titled What Flood, and I have copied that dataset from this file into our StatCrunch folder, our StatCrunch data, and we want to produce a line plot for that data. So again, going back, I'm going to close out of this, and I'm going to go right over here. I have the data, the year of the flood, and the amount of the flood. Year would definitely fit on the horizontal axis, the x-axis, and flood on the y-axis. So again, to re-illustrate, I'll go to graph, go to scatter plot, then my y-x variable must be the variable for the year, for time, and the y variable would be what has been measured over those years, which is flood. And I will go back. I'm going to indicate that I want a line graph, and the line size I like to make it bolder. And let us see. So go to compute, and we have this trend line. So from this trend line, we can see an almost linear positive what? Trend line that is climbing over the years. That would be a good report statement. as far as this data set is concerned. So please keep in mind that line graphs are very useful for representing trends in time series data over time. And that helps us to answer this description, which is to look at the type of relationship that exists between year and the amount of federal flood insurance, which is almost linear and positive. It is trending upwards over time. And so that might give us some reason to um, consider how much we want to align ourselves with this claim by USA Today. Let's look at yet another representation of the relationship between two numerical variables. We usually use what is called a scatter plot or a scatter diagram. And you will note that in this scatter plot on your visual, you have one numerical variable, and you have another numerical variable. So anytime we want to look at if there is a relationship between two numerical variables, the appropriate graph or plot is a scatter diagram. Well, we want to see if it is possible that one is related to the other. In particular, if you see a trend, a consistent trend, this will be the trend line in this case, in which case we can say that there seems to be a relationship between percentage with bachelor's degree and per capita income. In other words, we are looking at whether this variable, the y variable, otherwise called the response variable, as we discussed in Unit 1, if it depends on the explanatory variable. The explanatory variable is also called the predictor variable. It is also called the independent variable, whereas the response variable is also called the dependent variable and represented by on the y-axis, whereas the explanatory variable is represented on the x-axis. So as far as this question is concerned, the explanatory variable is on the x-axis, the response variable is on the y-axis. And we are required to describe the relationship between the two variables. Well, I can see in terms of the different characteristics, I can see a positive. This talks about the direction, linear. This talks about the form, uh, a positive, linear, and I can see that most of the points are clustered together. So I can say moderately strong. It's talking about the strength of the relationship. And do we have any outliers? I wouldn't say that there is any point that is particularly straggling away from the cluster of what the data values, uh, relationship, relationship between the two variables with no extreme outliers observed. So we have that piece there. Can we conclude that because of this relationship, can we say that a bachelor's degree, that having a bachelor's degree increases one's income? Well, this is where we remember that two variables being associated or being correlated does not imply causation. Correlation does not necessarily imply causation. So the correct answer to this question is no, we cannot. All right. Can we generate a scatter plot from scratch? Let us see another example. A bank issues credit cards to what? Customers. And that is because, and that is along the lines of the fact that a major factor in determining whether a credit card will be profitable to the bank is the average monthly balance that the customer will maintain on the card that will be subject to finance charges. Bank analysts wish to determine if there is a relationship between two variables, average monthly credit card balance and the income stated on the original credit card application. These are two numerical variables. So what kind of visualization or graph should they use? And that should, as we earlier state, that should be a scatter plot a scatter graph or scatter diagram. And why is this choice the right one? Because we have what? Two numerical variables. We're trying to look at the relationship between two numerical variables. So the correct plot should be a scatter plot. We're now required to create the visualization we chose using the dataset provided. Before we do that, we need to think about the roles of your y and x-axis. Which variable would depend on the other? I would say that average credit card balance would probably depend on the income. So on the y-axis would be average credit card balance, and on the x-axis would be the income stated on the original credit card balance. Let's take a peek at the data set. So going back to the data set, I have what? Income and credit card balance. I would like to draw a scatter plot, not a line graph this time. So for this, which depends on the other? I would think the credit card balance would depend on the income. So credit card balance would be my y variable, and I want it to depend on the income. And in this case, I want points because I want a scatter plot, not a line graph. And I can go ahead and drag this up a little bit and then click on compute. Let's see. Yes. So I have this right here. Looking at the points might present another challenge. Is there a trend here? That might be difficult to see. If we zoom in on this, it seems to be all over the place. So let me see if I minimize it again. I'm going to try to impose or superimpose a trend line. So I'm going to go to overlay polynomial order of 1, and I want the best fit to do that automatically. So let me pull this up and let's go to compute. I have a trend line. So this suggests a somewhat negative linear relationship between the two variables. In subsequent chapters, we're going to delve a little bit deeper into this and see how to do some in-depth analysis in simple linear regression. Okay, here is another one, another picture here, where we look at the congestion cost per person and the peak period freeway. I can see a trend line here. So as far as what direction of the relationship is concerned, I would say negative. But these two are negatively associated, which means an increase in one tends to be associated with a decrease in the other one. Then about the form of the relationship, this is approximately linear. What about the strength of the relationship? That will be a function of how clustered together these points are. So I would say reasonably strong. I would say reasonably strong. Then lastly, do we have outliers or not? And I would say no extreme outliers here. That can be subjective though, but for me, I do not see an extreme outlier here. So I would say the relationship between congestion cost per person and peak period freeway speed appears to be a negative linear relationship that is reasonably strong, and there were no extreme outliers observed. So it is in this sense that we describe a scatter plot in terms of the direction, the form, the strength, and whether there are any outliers or not. These are key indicators of the association that might exist between these two numerical variables or absence thereof. All right.